Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video tutorial, we're going to be taking a look at what is the optimized bubble sort algorithm. Now before we start off with optimized bubble sort, I'm assuming that you already know what is bubble sort algorithm. If not, in the previous two video tutorials of this data structures and algorithms playlist, I've already covered bubble sort algorithm in detail. So make sure you watch that video and understand the working, and only then the optimized bubble sort will be much clear. And with that being said, let's get started. So in this video, what we're going to do is we're going to understand how optimized bubble sort algorithm is more efficient compared to the bubble sort algorithm. We'll dry run the algorithm of both optimized as well as the normal bubble sort, and we will also see a program at the end of this video of optimized bubble sort algorithm. So make sure you watch this video till the end. So starting off quickly, what we will do is, as you can see on the screen, this is the very same bubble sort algorithm which we studied in the previous video tutorial. So this was the same algorithm, and here we will directly start with the dry running of this algorithm on this array which is of size 5 and it has some integers in it. So we want to apply this regular bubble sort algorithm on this array and make it in ascending order, and right now it is not in any order, right? And again we will keep a track of all the variables involved, and later we will apply the optimized bubble sort algorithm on this same array to see how it is more efficient compared to the regular bubble sort. Okay, so I'm gonna go a little fast because I'm assuming you already know this algorithm. What happens is, in bubble sort we compare the adjacent values. If the first element is greater than the second, we do the swapping, and if it is not, then we move on to the next two elements. Okay, similarly the comparison happens, and after first round or after every round, the largest element in the array is shifted to the rightmost end. Okay, so when it comes to the regular bubble sort, if we are applying it on this array with a size of 5, we will start this algorithm. N is going to be 5. I initially is obviously going to go from I equals to 0 to I less than n. What is n? N is 5. So I has to be less than 5, which means that I value will go from 0 to 4, that is 5 times, right? So the outer loop is going to run 5 times. We will go inside. The inner loop is going to have a condition of j equals to 0. So j will start from 0 to j less than n minus I minus 1. So this is very important. We've already seen the meaning of this in the regular bubble sort, so I'm not going to explain it again. N is 5. I initially is going to be 0. So 5 minus 0, 5. And then again 5 minus 1 is 4. So j has to be less than 4, which means the inner loop will run from 0 to 3, that is 4 times. And this is for first round. So we will keep a track of rounds, okay? Because we want to calculate the efficiency of bubble sort algorithm versus optimized bubble sort algorithm. So whichever algorithm reduces the number of rounds and sorts this entire array in less rounds is going to be more efficient, right? And this is what we have to track, whether the optimized bubble sort algorithm can successfully sort this array in less rounds. Now, if you go inside this loop, the comparison is happening wherein we are checking a of j is greater than a of j plus 1. So when initially j is 0, j plus 1 is going to be 1. So 0 and 1 position is compared. So elements at 0 and 1 position are compared. So 5 and 2 is compared. So if phi, this value phi, that is a of j, is greater than the adjacent value which is 2, then we have to do the swapping. So right now phi is greater than 2, so we have to do the swapping, right? So again, this is something that we've already seen. So what I'll do is I'll quickly do the swapping and we will go through the rounds. So for the first round of the outer loop, we are inside the second loop, that is inner loop. So I'm going to run through the inner sub rounds quickly. Let me just write down the values first. 5, 2, 4, 3 and 6. So first comparison is happening between these two values and j is 0, right? So 5 and 2 is compared. Is 5 greater than 2? Yes. So we have to do the swapping. So 2 will come over here and 5 will come over here. Now j plus plus will happen. J will become 1 and the condition is j has to be less than 4, right? J has to be less than 4. Is 1 less than 4? True. Let me just update the j value over here also. So is 1 less than 4? True. So now we are comparing a of 1 and a of 1 plus 1, which is 2. So now we are comparing these two values. So is 5 greater than 4? Yes. So again swapping is required. So 4 and 5. Now again j will be incremented. J will become 2. Is 2 less than 4? Yes. Inside this we are again making that comparison. So a of 2 and a of 2 plus 1 is 3. So these two elements are compared. So phi is compared with 3. Is phi greater than 3? Yes. So again swapping is required. So 3 comes over here, 5 comes over here. Again end if, end loop, again coming at the start of the inner loop, j becomes 3. Is 3 less than 4? Yes. So we go inside this loop, again comparison is happening. Is a of 3 greater than a of 4? So we are comparing these two values. Is 5 greater than 6? No. So no swapping is required. Again end if, end loop, j becomes 4, and now condition becomes false because 4 is not less than 4, right? So we come outside the inner loop, end loop, and we go at the start of the outer loop. So first round is done, and after first round we have the result of 2, 4, 3, 5, 6. And now we will start with the second round. In second round, I becomes plus plus because I will run from 0 to 4. Initially I was 0, I will become now 1. Okay, and this is the round 2. Now in round 2, the only change that happens is this condition will change. So in round 2, again we will come inside this outer loop. We have one more inner loop, j will start from 0 only. Let's change 0. The only change now will be j will go from 0 to n minus I minus 1. I has become 1. So 5 minus 1 is 4, and 4 minus this 1 is 3. So j has to be less than 3. So j has to be less than 3, which means j will only run from 0 to 2. Which means this time it will run from 3 times. In the first round it was running for 4 times. In the second round it will run for 3 times. So let's do the round 2. Let me just write down 2, 4, 3, 5 and 6. And again inside this loop same the comparison is gonna happen. So initially j is 0, a of 0 and a of 1 is compared. So these two values are compared. Is 2 greater than 4? No. So no swapping is required. We will move ahead. J will become 1. Is 1 less than 3? Yes. We will go inside the inner loop. Again comparison. Now a of 1 and a of 2 is compared because j has become 1. So now we are comparing these two values. Is 4 greater than 3? Yes. So swapping is required. So let's do the swapping. 3 will come over here and 4 will come over here. Again end if, end loop. Again j will become 2. Is 2 less than 3? Yes. So now j will become 2 over here. We are checking a of 2 and a of 3. If you think I'm going a little fast, it is because I'm already assuming that you know all this process. We are just doing it because we want to track the number of rounds. Okay. So now a of 2 is 4 and a of 3 is 5. 4 and 5 are compared. We don't need any swapping because 4 is not greater than 5. So no swapping. End if, end loop, j becomes 3. And now the condition becomes false because 3 is not less than 3. So we come outside the inner loop. We come at the end of the outer loop. We go at the start of the outer loop, and now I becomes 2. Which means now we are beginning with third round. Now before we actually begin with the third round, if you observe in round 2 itself our array is already sorted. You can see 2, 3, 4, 5, 6. It is already in ascending order. So we do not really need a round 3 or round 4 or round 5. But in the algorithm we do not have any mechanism or any way to determine whether the array is already sorted or not. So this is one drawback of the regular bubble sort, which means that now this loop will still continue to execute and we will go inside this loop and again we will make the comparison. So round 3, round 4 and round 5 will still happen because we are not having any logic which will stop the algorithm here itself saying that the algorithm is already sorted. So how do we determine whether the array is already sorted before the 5 rounds? Because the outer loop you can see has to run for 5 times. And this is gonna happen even if the array is already sorted or not. So this is where the optimized bubble sort algorithm comes into picture. So how do we determine whether the array is already sorted or not? So let's see that algorithm. So before going to that, understand that this bubble sort will still execute and we will have 5 rounds. Okay, so I'm not continuing with the round 3, round 4 and round 5 because it is just this process is gonna get repeated. Inner loop, the inspection of a of j greater than a of j plus 1 and the swapping, but there will not happen swapping after round 2 because all of them are already in sorted order, right? So a of j will never be greater than a of j plus 1 after round 2. And this logic is where the optimized bubble sort comes into picture, which will keep a track of whether swapping has happened or not. Okay. So remember that in bubble sort algorithm, the number of rounds are 5. Okay. Now let's see optimized bubble sort. Okay. So as you can see on the screen, this is the optimized bubble sort algorithm from start to end. And in the yellow boxes are 3 extra steps which are required to make this bubble sort algorithm optimized. So on the right you can see we are tracking n, I, j and rounds and one more new variable which is called a flag variable, which is basically a boolean type variable which will store false or true. So what does this variable do? Let's find out in this algorithm by running it. Apart from these three lines, the bubble sort algorithm logic is the same. We have the outer loop which runs from 0 to I less than n. So n is 5, we are using the same array. Okay, n is 5, which is the size of the array. So outer loop will run from 0 to 4, which means basically 5 times, right? Now once we go inside this loop, we are keeping this flag variable as false. So I'm gonna write f over here, f for false. Okay, remember f is for false. Now we go inside this inner loop. Now inside this inner loop, what we are doing the same thing that we did in bubble sort. The basic bubble sort algorithm, we are running from j equals to 0. So let's do j equals to 0. I is 0 also, and this is the round 1. Okay, let's track these numbers also. J is 0 and j will run from j less than n minus I minus 1. So j should be less than 5 minus 0 minus 1, which is equal to 4, right? So j has to be less than 4, which means j will run from 0 to 3, which is 4 times. So just like the regular bubble sort, for the first round, the inner loop will run only 4 times. Now inside this, we are again doing the comparison. So we'll start comparison. Let me just write down this array over here also. 5, 2, 4, 3 and 6. Now we are comparing a of j with a of j plus 1. What is j initially? J is 0, you can see. So a of 0 is compared with a of 1. So these two values are compared. Is 5 greater than 2? Yes. So swapping is required, right? If a of j is greater than a of j plus 1, what we are doing is, before we do the swapping, we are setting the flag to true. So now this flag variable is now become true. I'll write t for true. Okay. Just remember these values, we are tracking it, and then we are doing the regular swapping. So let's do the swapping also. So 2 is swapped with 5. Okay. And if end loop, again we come at the start of the loop, and now j becomes 1. Okay. So is 1 less than 4? Yes. So we again go inside, and now we are checking for a of 1 and a of 2. So now we are checking these two values. So other than these flag variables, the rest of the sorting algorithm is just as the bubble sort only. So now we are comparing 5 and 4. Is 5 greater than 4? Yes. So we again go inside this if block. We again set flag equals to true. It is already true. Then we do the swapping. So let's swap 5 and 4. 4 comes over here and 5 comes over here. End if, end loop. Again j plus plus. So now j becomes 2. Is 2 less than 4? Yes. Let me make the change over here also. Now we are saying if a of j, that is a of 2, is greater than a of 3. So we are checking these two. Is 5 greater than 3? Yes. So we have to swap 5 and 3 also. So 3 comes over here, 5 comes over here. So swapping is done. Flag is already true only. Again end if, end loop. J now becomes 3. Is 3 less than 4? Yes. So let's compare a of 3 and a of 4, which is 5 and 6. Is 5 greater than 6? No. So we don't go inside the if condition. We directly come at end loop again. At the start of the inner loop, j now becomes 4 and the condition becomes false because 4 is not less than 4. So we come outside this inner loop. After we come outside this inner loop, one more checking is done. We are checking if flag equals to false, then break. So this flag variable becomes only true when swapping happens, right? Because whenever a of j is gonna be greater than a of j plus 1, we need to swap them. Only that time we are doing this flag equals to true. So if this flag is false, which is the initial state of the flag, it will mean that we did not do swapping anytime inside the entire array. And that would ultimately mean that the array is already sorted, right? Because we only need to swap adjacent variables or adjacent elements when they are not in order. When they are in order, we don't need to swap them. And if in the entire array, we did not swap even one time, then the flag value will always be false because we will never go inside the if block. So this is what we are checking over here. That is, if flag is equal to false, it would mean that we did not swap any time inside this inner loop. And that would ultimately mean that the array is already sorted and we have to break. However, after the first round, when we come at this stage, we are checking flag equal to false. We know that the flag is not equal to false. It is equal to true. It was set true initially. So nothing will happen. Okay. We will come at the end of the outer loop. We will go to the start of the outer loop, which is this position. And now I will become 1. So this, after first round, we have 2, 4, 3, 5, 6. So we will start with the round 2. I will become 1. Okay. And j will again start from 0. So let me just write down these values 2, 4, 3, 5, 6. So now we are again starting with the second round, round 2, I has become 1. Again we set the flag as false, right? So let's change the flag T to F. So now we come at 2.2, which is the inner loop. Again j will start from 0. Let's make j equals to 0. To j is less than n minus I minus 1. What is value of n? 5. What is the value of I? 1. 5 minus 1 is 4 and 4 minus 1 is 3. So j has to be less than 3, which means that now j will run from 0 to 2, which is 3 times. So you have to count the 0th value also as a 1 round, right? So 0 to 2 is 3 times. So for the second round, obviously the inner loop is going to run 3 times. So again, let's do the comparisons. Now we are saying if a of j is greater than a of j plus 1. Again comparing 0 to 1. So we are comparing 2 and 4. Is a of j, which is 2, greater than a of j plus 1, which is greater than 4? No. So we don't need any swapping, right? So we will not execute these two steps. We will again come at the end of the loop. Again come at the start of the loop. J will become 1. So is 1 less than 3? Yes. So we will go inside again. So now we are checking a of 1 and a of 2. That is these two values. So now we are saying is 4 greater than 3? So this is true, right? So now we will go inside. Now we will make the flag as true, okay? Because 4 and 3 has to be swapped. So let's swap the 4 and 3 values. 3 will come over here, 4 will come over here. And now we also have to do the flag as true. So let's do that. I'm going to write T for true, okay? Now we will say end if, end loop, that is ending the inner loop. Again come at the start of the loop. J plus plus, j will now become 2. Is 2 less than 3? Yes. So now I have to check a of 2 and a of 3. So we are checking 4 and 5. Is 4 greater than 5? No. So we will not go inside this if block. So these two will not be again executed. End loop, come at the start of the inner loop. J will become 3. Now 3 is not less than 3, right? So now we will come outside the inner loop. When we come outside the inner loop, we are at step 2.3. So again we are checking if flag equal to false. We know that the flag has become true right now. So nothing will happen. Okay, we will not break out of this algorithm. So remember, this step is where we are checking whether the flag variable has become false or stayed false. If it is false, then we have to completely break this algorithm. It is still not broken. So now we will end loop, and again we'll end the outer loop and come at the start of the outer loop. And now I will become 2. Okay, because I plus plus, I has to run from 0 to 4. So now I will become 2. And now we are starting off with the round 3. Okay, so let's do that. So starting off with the round 3, if you see at round 2 itself, our array is already sorted. Okay, so now let's see how optimized bubble sort algorithm works for round 3. So for round 3, I has become 2. We have again set the flag to false. So let's do that. Coming inside the first loop, step number 2.1 is setting the flag to false. So let's do that. So I'm going to write F for false. Now we come inside step number 2.2, which is the second inner loop. J will start from 0 to j is less than n minus I minus 1. So phi, which is n, minus I, which is now become 2, minus 1. So 5 minus 3 is 2, right? So j has to be less than 2. So j will run from 0 to 1, which is only 2 times. Let's go inside. We will start with j equals to 0 only. So 0 and 1 is compared. So let me write down 2, 3, 4, 5 and 6 over here. So this is round 3. Comparing 0 and 1. Is a of 0 greater than a of 1? No. Is 2 greater than 3? No, right? So we don't need any swapping. So these two steps are not going to be executed. We will come at end if. We will come at end loop. That is ending inner loop. Again go at start of the inner loop. J will now become 1. Is 1 less than 2? Yes. Let me update j value over here also. Now we are going to check a of 1 and a of 2, right? So a of 1 is 3 and a of 2 is 4. Is 3 greater than 4? No. So again, we will not go inside the if block. We will not execute these two steps. We will end if, end loop, again come at the start. J will now become 2. Now 2 is not less than 2, right? So now we will come outside this smaller inside inner loop. So we will come at 2.3. Now if you check if flag equals to false, if you see the flag variable is still false because we never got inside this if block where flag was becoming true because there was no swapping. So now if flag equal to false, then break. So this statement is going to completely break this entire algorithm and stop this algorithm. We will come outside the outer loop also. So the outer loop was supposed to run from 0 to 4, that is 5 times, which means I was going to go till 4. But because of this statement, we broke at this round itself, that is at round 3 itself. And once we come outside the algorithm, we have our sorted array at round 3 itself, which is 2, 3, 4, 5, 6. So you can see that in optimized bubble sort, what happened is we only required 3 rounds to sort this same array, which was taking 5 rounds using the basic bubble sort algorithm. So hence you can say that the optimized bubble sort algorithm is more efficient compared to the bubble sort algorithm, the normal one, because it takes less rounds. And it takes less rounds because we are keeping a track of whether the array is sorted or not using the flag variable. So yeah, this was the algorithm. Now let's quickly actually see the program. We only have to make 3 changes in the program of the original bubble sort algorithm, and we've already written the code for bubble sort algorithm in the previous video. So we will only make the small change and keep a track of the rounds. So let's jump to the coding part. Okay, so as you can see on the screen, what I've done is I've already typed in the code for the normal bubble sort. So this is the not optimized or original bubble sort algorithm. And we've already seen this in the previous video tutorial, so I did not type the code again. Don't worry, I will be sharing this entire code with you guys. You can find the link in the video description to this entire code. And in the main function, what we are doing is we are creating an array of size 5. So this is not supposed to be taken. We are hard coding it. We are asking the users to enter 5 integers. We are taking that using cin. We are using C++, but you can also use any other programming language. The algorithm is going to be the same. So what I'll do is I'll drop the optimized and normal bubble sort algorithm on the right. Right now you can see the normal bubble sort algorithm. Coming back to the main function. So after taking the values from the user, we are printing before sorting. So we're using a for loop to print the values inside the array. Then we are calling our bubble sort function. So this is that bubble sort function. Now inside this bubble sort, what I'm doing is I'm just keeping a track of the rounds. That is the count of how many rounds are required. So in the original bubble sort algorithm, obviously we are going to need 5 rounds, right? Because it is inefficient. So at every iteration, I'm saying round plus plus. So that's why the round value is incrementing. Other than that, the algorithm is exactly the same. We have 2 loops. We have the same condition. You can see the algorithm on the right hand side, and it is exactly the same, which is converted into code. And this is the swapping logic. And lastly, I'm just printing the number of rounds over here. So after we call the bubble sort, I'm again printing the array. I'm saying after sorting. So when we are calling the bubble sort, we are passing this my array. And when we pass an array in a function in C and C++, it is passed by address. So keep in mind. So this bubble sort algorithm function is taking an array by address, and this A is basically just pointing to this my array. I hope you know the concept of pass by value, pass by reference, and pass by address. If not, I have another video on this. In fact, I have a complete C++ programming tutorial series. You can check that video in that playlist. And yeah, this is the basic bubble sort algorithm. Let's try to execute this. I'm going to say compile and run. And now let's try to enter those same values that we had entered. So the values were 5, 2, 4, 3, 6, right? Let's hit enter. And you can see before sorting, it is 5, 2, 4, 3, 6. Then we called the bubble sort function. And inside that we said number of rounds equals to 5. So we required 5 rounds. And after sorting, we got the sorted array as 2, 3, 4, 5, 6. Right? So this is the basic bubble sort algorithm. Now let's see the optimized bubble sort algorithm. I'm going to close this. And this is the general bubble sort algorithm. Let's write the code for optimized bubble sort algorithm. Okay, so I just pasted the entire optimized bubble sort algorithm because essentially it is going to be the same, just like bubble sort. But the only change happening over here is we are keeping a track of this flag variable. Now on the right hand side, you can see the algorithm for optimized bubble sort. So inside the first loop, the outer loop, we are creating a flag variable and assigning false. Now this rounds variable is just keeping a track, as I mentioned, because we want to see how many rounds are required, right? Then coming in the inner loop, we have the same swapping logic, and along with the swapping logic, we also make the flag equals to true. That is happening inside this algorithm also. You can see the flag becomes true, and then we do the swapping. And when we come outside the inner for loop, we again make the check if flag equals to false. We are breaking out of this algorithm, and we are simply printing out the number of rounds required to do the sorting. So coming to the int main function, I'm just going to change this bubble sort to optimized bubble sort. Okay. And I'm going to pass the same array. Let's save this. And now let's try to run this. Don't worry guys, I'm going to be sharing this code. You can also pause it and type it along. I recommend that you type yourself. Let's go to execute, compile and run. So again, let's enter the same integers 5, 2, 4, 3, 6. Hit enter and there you go. Now you can see before sorting, this was the array. Number of rounds equals to 3. So this is where 2 rounds were saved, and after sorting we are getting our sorted array. So our optimized bubble sort algorithm is working perfectly fine and it saved 2 rounds. Now 2 rounds might sound less, but imagine if you had hundreds of elements and hundreds of items in the array. The size of the array is very large. In that case, this algorithm might save lots of lines of code or lots of iterations basically, and then your algorithm will run faster compared to the regular bubble sort algorithm. So yeah, this was the optimized bubble sort algorithm. I hope you've understood what exactly optimized bubble sort algorithm is doing and how it saves and makes the program more efficient. And that's it for this video, guys. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and I'll see you guys in the next video. Peace.